Yeah, sorry for the inconvenience there, and also thanks for staying, all of you. I know it's hard, like those times at the university, staying at the last class, not feeling asleep, and yeah, it's not going to be a test, so I will try to make it as entertaining as possible. If not, then let me know also otherwise, so I can improve it. So I'm Socrates Ruiz. Come from Mexico actually, but been living in Germany since 6-7 years ago. I work in a consultancy company where we have worked with different kind of projects, mostly focused on data-related ones. And since 2 years ago, I'm part also from the Community Builders program, which is a really great way to contribute back to the community with the sessions about the things that we do at work or that we learn from different conferences also around the world. So let's start. So today I want to expose to you a use case where we had to implement a whole data platform from scratch. There was this directive from the top level management of the customer that they want to now be cloud native and migrate their system from on-premises. So that's with how I want to start the session today. So to give a little bit more context is like, okay, where is that we started for this project is we are talking about a customer that is working on the public sector that wanted to do a migration from some systems that were on-premises to cloud. They started to use Azure, but they were not quite happy with it due to some restrictions on the configurations that they can do there. They were using Azure/Databricks. That will become relevant in a few. So now they say like, okay, let's switch to AWS, and then I will still want to have this hybrid connection between AWS and on-premises. That was done by another team. So the other team already then integrated, as we saw in one of the past sessions of today, with Direct Connect, and as a fault-tolerant solution, or well, as a backup, there was also a VPN connection there. And because of also the nature of the project, security was really a big requirement there in both terms to have everything encrypted and ideally that the traffic will stay on AWS. And so that's where things got also a little bit interesting once we start to work with the data-related services. And lastly, due to also being on the public sector, the budget that they had were not that big, so they were also quite emphatic on the sense that we should keep the cost as low as possible without sacrificing too much the performance, and also to have some kind of control on the observability of, okay, how is our costs going on, and not waiting until end of the month and see the bill, it's $10,000. Like, okay, we wanted to have some guardrails there, so that was like, where were we? And as in the movie, any movie, it's like, okay, it's a start, a middle point, and an end. There should be a path to follow for the character or whatever on a trip. It's like, okay, where should we go? In this case, as I mentioned, it's a data-related project where nowadays we have different kind of scenarios to implement. I started to work once we have this really big word several years ago of big data with the 3 V's and everything so on. So from there, we have several new tools, new paradigms, and some of them were like, okay, It started, I guess, with way before big data, with all the data warehouses concepts. Then afterwards, data lakes became trendy, and then now we have lake houses, and we could talk about also data vaults or data mesh approaches. So the customer also was not quite sure what they want to have, but the only thing that they will want for sure is that the team, didn't want to be the bottleneck of for the rest of the teams to implement their applications. So with that in mind, it's like, okay, we dig deeper into these three different solutions, destinations in this case. It's like, okay, let's start. Let's see if just a data warehouse will be more than enough in order to provide and enable the end users teams, the business teams, with a proper solution for their needs in this case. But we found out that in this case, data warehouses has pros. It's something that is quite stable. Performance is really good, normally. But at least the ones that we were checking on, they are quite expensive. The flexibility that you will have with the data types, it's not as much or as wide as with, let's call it open source platforms or something similar. And they create this so-called lock-in, right? Vendor lock-in. So on the other way, on the other hand, is like we have the data lakes, where then we have our hands are untied in order to have more flexibility on the types of data that we could have there, unstructured, semi-structured, or structured there. But we have that flexibility with the expense that we lose some commodity in terms of, for example, we cannot do any more transactions as a high level. And also, like this asset concept is that we need to sacrifice normally one of those in order to implement these kind of platforms. And the governance, at least on this particular project, became a really big topic, in the sense that we identified that for a data lake, to find a proper data governance tool to implement what business required, it was also quite not so easy to implement. And lastly, as I mentioned, I think that the term of lakehouse became quite popular, more with Databricks. And as the customer already had this experience with Databricks on Azure, they say like, okay, and can we have that on AWS? And it's like, yeah, okay, Databricks is also, can run on AWS. But one of the few disadvantages from my point of view is that the configuration is not as out of the box as with Azure. Like in Azure, it's already like some service, and on AWS, it's like, okay, I need to go to the marketplace and then make the subscription and blah, blah, blah. And then the customer say like, no, Databricks, let's put it on hold in the meantime that we create a proper Databricks account, and then maybe we do something there. But in the meantime, let's go full AWS. And we started again to talk more about on the lakehouse concept, because it brings the best of both worlds in terms of data warehouse and data lake, because we have the flexibility of handling different types of data there. And it's also really well suited for ML use cases, and also enables the other spectrum of users. From my point of view, the business guys, which are more familiar with BI tools, business intelligence tools. But from the engineering side, which is, from my point of view, in the middle, puts a lot of complexity in order to properly configure and deploy and maintain, operate all this platform architecture of a lakehouse. Plus, outside Databricks, like implementing it with open source tools that are there, it's still a maturing ecosystem if we compare it with data warehouses that are there from more than 10, 20 years. And Lakehouse is still something recent. So, like in the movie of Titanic, it's like, okay, we will start doing poker, a gambling time, where we will say like, okay, which tool will be the one that we want, but, depending on the requirements of most use cases that we will have, which it's like most of them are read intensive. That is obviously the writing part of ingesting the data, but aside from that, like modifying it, it's at least up to now not something that is so required from business. So it's mostly read analytics. The data, the source data, it's actually quite big, I will say, in the sense that normally I have seen projects where once we partition the data, we face the issue of having micro partitions, which is not really quite good for the tools in terms of performance. And on this case, actually, we got the other way around. It's one of the few projects where I see like, okay, one partition is, we're talking about gigabytes, which then again, for some tools, it's that even too much. So we needed also then to repartition it again to have some things around 128 or maybe 265 megabytes. And so whatever tool or whatever service that we will choose needs to handle that. As I mentioned before, ideally, the data should not travel over the internet due to compliance, and also on the data part, we needed to be consider the GDPR part. And as I mentioned before, the team background was mostly business analysts and data scientists, and because the engineering team was quite small, and but the end users that actually will build the applications are mostly business analysts, data scientists, and in the ideal world, I guess they will have also some skill sets in order to deploy their own infrastructure if we will want to give them that capability. But it's really hard to know for infrastructure, also for network, and then also on top of that for whatever these guys do in terms of, okay, the reports that I need to do, the experiments that I want to do on SageMaker. So it's something quite complex. So that's like the background. Then we did a first iteration where we felt like quite happy, like, okay, yeah, we have our ideal scenario where we will choose these services, these data file types, and then we will deploy it on it. For the storage, it was like, okay, it's, I think, quite common to use now S3 for that, to store all files or objects there, and then connect S3 with all the other different data services that are in the AWS ecosystem. One of them is Redshift. With Redshift, it's like, okay, we can talk with S3 either by unloading or copying the data from the buckets to Redshift, or if we want to talk directly with S3, there is also Redshift Spectrum. So that was at the beginning why we choose this part. Other option was to also use Snowflake, for example. That's something that we were discussing about, but at the end we remain like, okay, let's keep it simple. Let's use it only the AWS ecosystem and not bring another third-party tool at the moment. Let's see how it goes. Due to the way that they experience the behavior on Databricks, is like they bring on the table Delta Lake. It's a file type which uses Parquet on the background. As they were happy with the performance on Databricks, they were like, okay, let's also use it for AWS. So the performance, we will expect that will be similar, but that brought some issues there that I will talk about in a sec. And then for movement orchestrations, I put a movement because ETL or also other kind of wordings can obviously depend on our definitions. So I think movement is a quite wide concept that fits there. For Glue, it's like, okay, we will use it in order to do some transformations and also to send some queries to Redshift. So also the data that is on Redshift, also if there is some also transformations to do there. Lambda with the step functions for orchestrations for our pipelines and to move them on the different medallions that the Lakehouse concept recommends, like, okay, we have our bronze layer where the raw data is. Whenever we do some cleaning, some first steps of transformations, we will move it to the silver layer. And then once we create and have the requirements from the business teams that how they want the reports, okay, then we will move it to the gold layer where they will be ready, the data will be ready then to be consumed from the BI tools or from the applications themselves. As I mentioned, that first iteration, it was like, okay, let's do it. We will conquer the world. And then it's where, yeah, well, on the movie, we know what, how Jack ended. So something similar happened in the sense that, okay, the storm is coming. First, we were creating the schema directly on Glue. That's one sample statement that we were using directly on the Glue part. Is like, okay, we will do, create the table with the delta properties as we were using delta. And we were happy at the beginning. The problem arose once we needed to do some schema evolutions because we needed to add some columns and we needed to change also some values there. We started to have a lot of errors. And at the beginning, we were like, okay, why is this happening? Is it part of the issue of configuration on Glue, or is it something related about the file types? Which, on this case, was because Delta, apparently, it's quite, how to put it in, my feeling is like, it's quite picky in how we store and handle the operations of the Delta files. Even though it says like, okay, out of the box, I will handle that, like Delta itself. But once we mix a lot of tools, because we were using the data from Glue, we were using the data from Redshift, and we were using the data from Athena. All this data was stored on S3, as I mentioned, but still, like for Redshift, everything looked okay. But for Glue, things were starting to sync, and Athena was like, okay, yeah, I also see things okay, so still not something we wanted to do. Plus, the integration with Redshift, as I mentioned, we were using Redshift Spectrum. Here, it's where also it started to become quite heavy for the team to operate the project, to maintain the project. Because for when you are using Delta, it's mandatory to keep track also on the partitions. Whenever we are updating the data on the Delta tables, it's needed to do this sentence or to set this property at the beginning on the creation of the table, and that's why it's here. But if we forgot to do this, then on every update or new write, we need to do this operation, which is kind of a nuance that the team found that like, okay, but we didn't have to do that in Databricks. In Databricks also it was not quite needed to do to add manually the partition, because as I mentioned, for Delta, it's mandatory to add this on the fly. And the thing is that with Databricks does it automatically on the background. Also the vacuum and the statistics calculations. But all of those operations, if you are using Delta outside Databricks and by yourself, which was this case, it was something that the team needed to automate it. Well, first create the script and then automate it. And all of this was needed because, as I mentioned, Redshift can read the data. In this case, it's an external table, read-only table. And these manifests are needed by Redshift in order to read these delta files. Otherwise, Redshift will throw an error, and that's where, again, we started to see the iceberg on our path, and then we say no, let's do more designs. Okay, let's see how our project is looking and how we want to draw a new draft and improve this. So this is where one of the first parts was to change the creation of the table, the definition, the DDLs. Instead of using and creating the definitions from the Glue code, we started to do it directly from Athena and then automated with Lambda. And then Athena on the background uses Glue Data Catalog as the source of truth where we are storing this metadata. And for the related Delta Lake issues, it's okay, and what happens if we switch to Iceberg? And this was done at the end of last year. So full disclosure, at the moment, S3 tables was not still announced. So we were okay, let's just switch to Iceberg because also Iceberg handles our pain points or seems to handle our pain points, which is number one, we don't need to add the partitions manually every time a new one is created. That's automatically done by Iceberg, and Iceberg creates the manifest files also automatically, so that's also a big plus. There are also some out-of-the-box features on Glue Data Catalog that do the compaction of the files. It handles the orphan files, also the deletions, and some snapshot retentions that also helps whenever we have the requirement to do a time window kind of query. And as I mentioned before, it's also compatible with Redshift, Spectrum, with the constraint that at the moment up to now, it's only compatible with version 1 and version 2. And at the beginning, we were using Glue version 4, which has quite old versions of Hoodie, Iceberg, and Delta Lake. So we needed, at the time, to manually add the libraries, the dependency libraries to our jobs in order to use recent versions for Delta Lake on that part. But then version 5 of Glue was released, and it came already with Iceberg 1.6.1, which at least allowed us to do the POC, and then we found, okay, it's stable enough, then let's add the dependency for version 2. Iceberg is currently in version 3, though the version 3 is still not marked as stable, FYI. And since it's still not compatible with Redshift, we say okay, we are not going to use it still, but let's switch to 2. And the actual result was really quite well, because now we lose all those previous errors and then allowed us to actually focus on delivering the infrastructure ready for the teams to start doing implementing their use cases. Quick about the other findings that we had, talking about, for example, to the network. And is that, as I mentioned, we had an hybrid setup. There we had a DNS server on premises of the client that in order to provide the service to our Glue jobs, we needed to use our Route 53 outbound resolver. It's really quite easy to integrate it with VPC and then Glue in this case. For debugging, we use flow logs and private link in order to keep the traffic within the VPC and within our own premises. Some pain points that we had is that the number of glue jobs that the project had was getting too high, and that created us some learning that is, be careful with glue connections, talking about network connections. When you connect glue directly with your VPC, per each worker, and depending on the glue job, it's like, okay, if the glue has 2 DPUs, that will mean that it will create 2 workers on the background. And for each worker, elastic network interface will be created. And each interface will consume 1 IP. So we require more, at one point, more IPs. And luckily for this project, we were able to increase then the size of the VPC, which was okay. But for other projects, we couldn't do that. So it's where actually it's quite important that you count for that, even on data-related projects. And lastly, also similar to Glue, with Lambda, you can attach it to a VPC, but there is a big difference that Lambda uses a so-called hyperplane ENI, and on that network interface, the advantage is that it can be shared across multiple Lambda functions, with the restriction that they must use the same security group and be on the same subnet. And it scales automatically, so if your functions demand more network throughput, it will instantiate another network interface automatically, so that's a really cool feature. And lastly, the spectrum. Here is where something to really keep in mind is that Redshift spectrum, Redshift itself, it has 2 versions, the cluster one and the serverless one. With the cluster one, you actually see the, let's call it like the EC2 instances. They are actually Redshift clusters, but still you see a panel there where you need, or the teams needs to operate somehow those instances similar to RDS. It's like, okay, I need to configure it, I need to scale it if necessary, depending on compute, storage, blah, blah, blah. And with serverless, you forget about that. You just create your serverless namespace, the workspace, and then, okay, it will automatically scale if provided the proper configurations. And both type of Redshift clusters can use on the background a spectrum in order to communicate with external tables on S3, and then those tables can be on Delta Lake format, Parquet format, CSV, or on this case, Iceberg. But the restriction is on the network part that you cannot use the VPC enhancing feature, which is the way that Redshift connects directly to the VPC. So Spectrum still is the traffic is still within AWS, but it travels for a little bit outside the same AWS account, because AWS in the background has their own account, and that's where they need to start a little bit, I guess, some magic in order to then do these integrations. Lastly, talking about also then advantages of then switching to Iceberg is that this is one sample state machine that we have in order to move the data through our different medallions. We started, it's quite simple, but actually that's the beauty of the use cases. Most of the use cases that we implemented on this project, it was that it was more than enough with this state machine, which we started with the bronze layer, do some magic with glue, then switch back to the silver layer. Sorry, this is ingestion on raw bronze, and then silver. But as you can see here on this other part of the state machine, we needed to add a lambda, because that lambda at the beginning was the one creating manually the partitions on the table. So after we switched to to Iceberg, that Lambda we could get rid of, and then it became also simpler there, and also run the crawler, glue crawler, automatically scans your data sources, on this case S3, and then it automatically also updates the metadata of those data sources on the data catalog. But that's where, since we switched to Iceberg, we didn't need to do that because that metadata is already on the metadata files created by Iceberg. So switching there to Iceberg allows us also to remove that part of the state machine, and then also simplified the whole end-to-end pipeline. Lastly, this is like the really whole picture of how the high-level picture of how the project was, it's now set up. With adding the part that for governance of the infrastructure and of the data, we were using services like config, organizations, IAM, because as mentioned, we are still like on these first, second, third iterations, which also came to what we want to do in the future, which I mentioned before. S3 tables were announced end of last year, beginning of this year, which is actual tables that use Iceberg on the background and are stored already on S3. Or learnings is that via the automation of creating this type of buckets has been evolving quite fast. So it's not so stable yet from my point of view, but we are getting there. The configuration with lake formation is also getting quite well, but still, from my point of view, lake formation does a great work when your whole ecosystem lives just in AWS, but since here we have dependency on some sources that are on the on-premises part, lake formation was not best suited for us. Also recently, SageMaker Lakehouse have made huge steps in the sense of with SageMaker Lakehouse, also on the background, services like Glue, Data Catalog, Athena, and other ones are used, but it grabs it in a really cool UI, but still, again, it's really quite evolving quite fast. So from our point of view, still doesn't bring this stability that the teams require, but still something to look for. And as I mentioned before, we are still waiting for compatibility between Redshift and Iceberg for version 3 because we are actually quite interested in new features like for partition sorting and also for lineage, which brings the definition of Iceberg version 3, but still it's something that is still not there, the configuration. So with that being said, thank you very much. Again, I hope it was not as long as I expected, and
it was
yeah.
Awesome. So it was really like this topic is going to create like a lot of noise in the future. If you can just get start seeing something other than AI. So thanks a lot for your for the talk. We can have some questions if there's any for Socrates. Okay, then I will give you this one as a gift from today.
Yeah.
Thank you so
Thank
much.
you.